Okay, hello everyone, hope you have a good time at Delphicon 2023. And let's get to getting physical in your games with Castle Game Engine. I'm Michalis Kamburelis, I'm the author of Castle Game Engine. I'm going to talk a bit about the engine, a lot about the engine, and I'm going to show you some demos of how to use it for some cool stuff. And I'm also going to put a special focus on some features that we did recently. So let's start with what is Castle Game Engine. Well, it's a free and open source game engine, first of all. So you can go ahead and you can download it right now and you can use it. It's all completely free. The source code is available. Go ahead and have fun. It's an engine suitable for both 3D and 2D games. So, for example, you can make a first-person shooter game, or you can make a 2D game where you view some map from the top, or you can mix them. For example, you can have a two-dimensional game where something is scrolling, for example, but then some of the objects may be actually in 3D, so they can have rotations in 3D, they can have lighting, they can cast shadows, and so on and so on. So, 3D and 2D. Our, I guess, main feature since some time is a very powerful visual editor. I'm going to show you a lot of it today. The idea is that you can design user interface, three-dimensional worlds and two-dimensional worlds of your games inside Castle Game Engine Editor. It's kind of like other game engines that you may have known about. And yeah, you can do a lot of stuff there, and of course it integrates nicely with the code, because everything you do there, everything you see there, well, those are just Pascal classes. Everything you see here, they're like properties, well, those are just properties of Pascal classes. So it's a powerful visual editor, and everything you see there, it maps nicely to a simple object-oriented Pascal API under the hood. We do support a number of formats, in particular GLTF and X3D, and also Spline. That's a common animation format for two-dimensional models. It's using Pascal, as you can guess. So our code is what I would call a clean object-oriented cross-platform code, where everything is done using Pascal, like no tricks. It really works on a number of platforms. And we support Delphi. In particular, we support Delphi Community Edition, the free version of Delphi. So yeah, no excuse not to use it, basically. The engine is also cross-platform. We support a number of desktop platforms: Linux, Windows, macOS, FreeBSD, mobile, Android, iOS. We support also Nintendo Switch, Raspberry Pi, though there is a small disclaimer here. With the Delphi, we only support Windows right now. This is going to be rectified very soon, but yeah, we want to support all the other platforms with Delphi too. So, okay. So, as I said, like, go ahead and just get it from our website. You can install it, you can use it right now, today, completely free, completely open source. So, I guess one of the excuses for doing this talk is that we will have very soon a new release of the engine, 7.0 Alpha 3. We're kind of nearing towards something big. So, the 7.0 Alpha 3 features a number of, well, I would say big things, and one of those is physics, and I'm going to focus on physics a lot about in this talk. So we have some new components, how to define physics in a really comfortable way. You can also use forces, like you can say from code that, you know, something is pushing something else with some force. You can run the physics simulation also in the editor, and you have joints and a few other features related to physics. We also have kind of upgraded our support for shadows. We have shadow volumes and shadow maps, and in particular the shadow volumes are it's just a checkbox. You can activate it in the engine, and that's what it should be. I mean, it's very simple to use now, and that's actually a big thing. I mean, it makes them so much more useful. We also support tiled maps. We did support them a long time ago. Our support right now is kind of better. We support a huge map, we support maps with animations, they can even be 3D. So we support a lot of more features about how to design your maps using tiled. If you don't know what it is, it's a very cool map editor, and I'm going to show it to you later. Okay. We also have a components to just drop the engine rendering on a VCL or FireMonkey form. But by default, the engine has kind of a dedicated window. We call it the T-Castle window. But with T-Castle control, you can also just put the engine rendering and processing inside a larger Delphi form, where you can place your regular VCL and FireMonkey controls, and it's all just going to be play nicely with Castle Game Engine Editor. So that's kind of the roadmap of the stock. Like, talk about the new features in 7.0 Alpha 3, and also to give you just a general overview of the engine. Now, looking into the future, well, we are aiming for a big 7.0 release, hopefully in March, so in next month. Don't worry about the slide, it's kind of a joke. I mean, the left column is not readable, I know. We have a lot of features done since the last release, and yeah, we want to actually have a new stable release 7.0, well, as I say, next month. Okay, and let's go with, I would say, the main part of this presentation, which is going to be demos. I'm going to show you how to use Castle Game Engine, using Castle Game Engine Editor, and of course using Delphi to design and implement something cool. So let's start. Let's start with the three-dimensional demo. So let's run the engine editor. Let's create a new project. You can create a new project from a number of templates. For this presentation, I'm going to use the 3D first-person shooter game template. Let's call it whatever. That's something unique. And once you open a project, you are greeted with such window. The main point of this window is to show you that your project has two views. One is the menu, the other is play. The view in Castle Game Engine is kind of a special concept. It's a lot similar to what Delphi form is. So the idea is that the view displays something, and each view has an associated Pascal unit where you can define how to react to user doing some actions like pressing some keys or some buttons in your view. So similar to Delphi applications, when you, at least at the beginning, when you start doing them, you are going to put your initial logic on a form, or this or that form, because you are going to just react to user input, and it's the same in Castle Game Engine view, yeah? So the view displays something and you have a unit that can react to user clicking on something, doing something, okay? So this sample project, well, this template of the project, it has two views at the beginning. It has the menu view that shows the user just some menu that you can choose to play or quit the game. And once you choose to play, then there's a ready code that switches the game view to play mode. And the play mode is, as you can see, well, kind of more interesting. So the idea here is that what I see is a three-dimensional view. So there's a viewport that has a background. This background is the skybox that you see around. And inside this viewport I have a number of scenes. A scene is something that comes from a ready model, ready asset, like in GLTF format, and I can design such scene, like a level or like a soldier. I can design it using, for example, Blender. And in fact, the enemies and the levels that have been designed here have been indeed made using Blender. So we can even open Blender and we can see how it looks like. For now, let's just see that, yeah, all those soldiers, they came from the soldier1.gltf file, and I can do a lot of stuff with them. For example, I can duplicate them, okay? So like now I'm using Castle Game Engine Editor, and I'm using those GLTF models of soldiers as kind of like a blocks, like a Lego blocks. Okay, so I can duplicate them, I can rotate them, move them around, and arrange them in any way I would like to. I can also change their animations, and here I can use any animation that I have designed in Blender. Okay, so I can do stuff like this. I can do stuff like this, and that's a little boring animation, and I can do stuff like this, and I guess I can also delete it. So all those things that you see, they have been somehow designed by Blender and then arranged in Castle Game Engine Editor to show you, well, to show some level design, and those creatures have also some very simple intelligence from code that allows them to walk basically left, right, and we will also be able to shoot them. So there's some ready logic in this template project, but not much. The point here is just to kind of get you started. What can I do here? Well, we have something called camera here, and the camera of course tells you what the user will actually see when the user will run this project. Yeah? So you can even increase this camera preview. For example, I can even move this camera. So when I'm moving the camera on the world, you can observe in the camera preview how it actually changes what the user will see. What's more, well, we have also the lights configuration in Castle Game Engine Editor. Although you can also design lights in Blender, it's actually much easier and, well, that's more efficient to just add lights in Castle Game Engine Editor and configure their look, color and so on in Castle Game Engine Editor. By default we have a light called directional light that casts shadows over the scene. Oh, it's already using those shadows that I wanted to mention. So this is the shadows checkbox, yes, so this is it. The shadows just work like that, you just toggle them with a checkbox. And yeah, this directional light casts those shadows. As you can see, when the objects animate, those shadows animate too, and that's exactly what should happen. And of course, if I would start, for example, to animate the lighting, well, then also the shadows move appropriately. And you can, of course, configure a lot of parameters of lighting here. To actually show it best, let me actually change the class of this lighting into something more dramatic. Okay, so let's choose the spotlight. The spotlight looks like this. Okay, so it's like a cone of lighting that shines on the level. And of course I can do a lot of tweaks here. For example, I can increase the intensity of it, I can change the color of it. Let's go ahead like this, okay? So I can configure the light like this, and it works. It allows me to give my scene the effect that I would like to have. And remember that everything that I show here, all those things, they are Pascal classes with Pascal properties. So everything I do here in the editor, but it also can be done using the Pascal code at runtime. So for example, what you see here, the T-Castle point light or T-Castle spotlight, it's a Pascal class. And what you see here, the intensity, the color, the beam width, well, those are Pascal properties of those classes. You are able to access those components at runtime and modify them in whatever way you want to at runtime to do whatever you want, whatever effect you would like to achieve. And then another thing I want to show on this three-dimensional demo is I want to show you how to attach behaviors to your transformation objects. So the behavior, the idea of the behavior is that it doesn't display anything on its own, but it just controls the parent to do something, well, something useful with the parent. For example, modifies the parent transformation. At runtime, actually, to all those four soldiers, we will attach some behavior that will make them walk left and right. But let's also attach some behaviors at design time, just so you can see, well, how they work, okay? So let's start and create a transformation called image, the castle image transform. This is something that you can use just to display an image, okay? And let's load here an image. I have an icon of our engine here loaded, and it looks like this. So it's way too huge, of course, to be useful, but of course I can make it smaller by adjusting the size of it. Well, let's, for example, to 2 by 2. Okay, so that's how the image looks like. Now this is not supposed to be impressive, okay? This is just a simple two-dimensional image displayed in a three-dimensional world. But why I'm doing it? Well, now I want to show you a behavior called billboard. So billboard makes the object that is attached to, it will make this object always oriented, such that the front of this object will face nicely the camera. So I can do like this, and there you have it. Now when I'm moving around this image, you can see from this perspective, you can see very clearly how it rotates to always face the camera. Although it's still a 3D object, it still stays at the three-dimensional position that it was, it's just rotating to face me, okay? So that's, I would say, a basic example of a behavior, and we're going to use this idea of behaviors much more later. So I guess let's do one last thing to make sure that everything works, which is to actually compile and run the project, of course. So to run the project using Delphi, to compile the project using Delphi, just make sure that in the preferences, in the compilation tab, the Delphi is selected and that we have detected the Delphi path correctly. I have already done it previously, so cool. So let's now click run. And this will do actual compilation of the project using the Delphi command line compiler. And once it finishes, it will also run the project. And there you have it. Okay, so let's click play. And our amazing design, including this billboard with the image and including those soldiers that walk around under the yellow spotlight, is working, okay? The project has also some radio logic for shooting, so I can also shoot those guys, right? So that's a basic first-person shooter game available in Castle Game Engine. And one more thing that I want to mention here is that, well, you don't have to build the project from Custom Game Engine Editor. You can also just open Delphi and you can run it, you can compile and run it from Delphi, which is in particular useful if you would like to use the debugger. So yeah, you can just run it from Delphi, you can use the Delphi debugger to debug your games, and yeah, it just works, because it's all just Pascal units underneath. So I guess the final, I would say, a generic demo before I jump into some physical specific features is how to actually do something from code using a custom game engine, because so far I have mostly shown you how to use custom game engine editor, well, but the very point of what I'm doing is that it's all available from Pascal code, and you can use Pascal code to do, well, anything you want in your games. So let's go ahead and do something simple. Let's open our three-dimensional demo again. And I want to actually I want to make two things, okay? So I want to make something happen when I press a button, and I also want to make something happen when I press a key, okay? And I want the something to actually be, let's play some sound, okay? So I have downloaded some amazing sound that sounds like zap, okay? And I love this sound, okay? So this is an amazing sound. I want to be able to play it in this game forever. So let's add a button to play it, and let's also make this zap sound be played when I press the Z key on my keyboard, okay? So like those two features I would like to implement now. Okay, so first of all, let's start and let's copy this file into the data directory of my project. So I'm just copy and pasting the audio file into the data of my project. I want to place it into the data subdirectory of it, okay? And now I want to define something called tcastle sound component, that is like an easy wrapper around an audio file that will allow me to configure some parameters of this file. I actually don't want to configure anything, and allows me to play this sound easily. Okay, so let's create a non-visual component, sound. There we can configure the URL of the file. Okay, once we have this, let's rename this component to sound zap, and let's also add a button to actually activate it, okay? So this is going to be our amazing button. I'm going to call it zap, and I'm going to make it very, very big so that you can see it, okay? Let's make the font also like a crazy big, I guess. Okay, so we have a button. Let's call this button also zap. So we have a button zap, and I want to play sound zap when I press this button. Okay, so let's go to Delphi. Let's open the unit called game view play, and yeah, and this is where I can configure what happens when the user is pressing various things. Okay, so from this thing I want to access button zap. So I'm just going to define it, declare it. The value of this published property will be automatically set when you actually load the design. This is actually similar to what happens when you load the Delphi form. Okay, and now I'm going to need the sound for this. Okay, and now I'm going to connect. So I'm going to assign an event. So when somebody clicks on a button, I want to call the method called zap, okay? And the method called zap is as well, because it's trivial declaration as you would expect, okay? So this is a method called zap, and what can I do here? Well, I can play a sound, okay? So I can use the sound engine singleton, and I can use the play method of the singleton. And here I can pass the sound that I actually want to play. And that's it, okay? So that's the way how you can play the sound. Let's actually make some log, okay? Just to confirm that it's all working perfectly. So that's one way to play something. When the user presses the button, we are going to play the zap sound. Another way to play something, and I'm going to show you because, well, while we at it, why not? So react to user pressing some keys. So the view has by default, the templates have a method, have defined a method called press on a view. And you can place some code there to react to user pressing some keys. For example, when the user will press the Z key, let's, as I said, I love this sound, so let's also play the zap sound, okay? And let's exit with true to tell the engine that the key has been handled. It doesn't matter in this case, but in case you have something more complicated and something else could process this key, well, this way we have told that this key, the Z key, is already handled. Okay, then let's compile it. No, alright. Okay, let's see what happens, okay? Amazing, so that's what I wanted. I can press this button as many times as I would like to, and it produces the debug output zap, and it's also making the sound I wanted. If I don't want to press on the button, I can also press the keyboard. I think I can make some music this way. Yeah, so this is the way that you can play sound from Castle Game Engine, and this is in general, this is a way how you can react to user pressing on a button or pressing some keys. So, and that's also, I guess, the basic demo of how you can use the Castle Game Engine API, and I'm going to show you more now. So let's jump into, I would say, the main course of this presentation, which is the physics. So one of the, I guess, more important features that we have done recently, thanks to Andrzej Kliański, who has developed a lot of this, and thanks to Craft Physics Engine from Benjamin Rousseau. So we have a really full-featured physics engine in Castle Game Engine, and it's kind of really easy integrated in a way that is really easy to use it from Castle Game Engine. So let's go ahead and let's see how to actually use it. For this purpose, I'm going to just create a new project starting from the empty template. Let's call it like this. And the empty template, well, as the name says, it's kind of empty at the beginning, so it looks like this, and that's cool. We're going to create a new user interface element, a viewport, a three-dimensional viewport, okay? Let's move it like this, so the frames per second counter is visible. And okay, what can I do here once I have this, well, almost empty viewport? Well, it's not really empty, right? It has a camera, it has a light, and it has a plane, just as a nice thing to place some stuff on it. Okay, so let's add some physical things on top of it. So let's start with a box, okay? That's our standard boring box. Let's make it look a bit nicer by creating another light, and only one of those lights will cast shadows like this. Okay, let's also make this plane a bit larger like this. Okay, I guess the light casting shadow should be like this. Okay, so that's our amazing box. Let's add something more. Let's also add a sphere. Okay, crazy. And then let's assign some physical stuff for them, because by default, well, those are just static box and static sphere. Nothing happens with them. They are just going to hang in the air by default. Now, if I want to, I can instead assign some physical components to them to make them be affected by gravity and be affected by collisions with each other. How to do this? Well, I'm going to add a behavior, and I'm going to choose the physics subsection, and I'm going to choose a collider. Now, for each object, you should choose like the most suitable collider. In particular for box, well, of course, there's a box collider that makes it behave naturally, and I'm going to do the same for sphere. Okay, so it's physics collider sphere. You can see on the left what actually happens. So when I'm adding a collider, it's adding a box collider. It's also adding something called rigid body. Those two components, rigid body and the collider, they kind of work closely together with each other. And now we can actually run physics. I can run the game and just observe it from the point of view from the camera. So the camera looks like this, and the camera will see everything, okay? But I can also use something called physics simulation inside the engine, and this is kind of a quick way to actually preview how your physics behaves. So let's see how it behaves. Okay, they go down into infinity, because I forgot one thing. Well, by default, the ground is not a physics object by default, and they fall through. Okay, but this is easy to fix. So let's add a behavior, physics, plane collider on the ground. and now they will behave like this. So they will stop here, okay? And of course I can duplicate those things to very quickly create something, I guess, more fun with it, okay? Let me just move the lighting somewhere there. And I'm just pressing now duplicate, Ctrl D. And this is, well, a very easy way to, of course, create some more chaos in your scene. So let's see how this thing behaves, okay? So as you can see, the box has reacted like correctly to the fact that it collides with the spheres underneath. It's pushing them around, it's rolling them, and so on and so on. And that's what should happen. Okay, so let's create something more interesting, okay? Because this is just a plane with some boxes, okay? First of all, let's start and create some, well, let's call it a simple level in Blender. I really just want to show you that you can design some easy things in Blender and you can load it quickly in Castle Game Engine. So how would go about it? So let's first save our scene. Let's open Blender. And let's create our amazing level in Blender. How to do it? Well, I'm just going to create a terrain, okay? So this is a quick way to design a terrain in Blender. There we have it, okay? And now I can easily load this terrain into Castle Game Engine. In order to make it available for Castle Game Engine, I want to export it. I want to export it to GLTF format. And the default export settings are actually good enough for the simple object, though I almost intuitively actually click some additional things which are apply modifiers and remember export settings, and this way the level will be exported to the GLTF file with, well, what I would call the most suitable settings usually. Okay, so that's our level, okay? How can I actually now access it from Castle Game Engine? Well, now I have the file called level.gltf in my data subdirectory. I can also preview it in Castle Game Engine. So if I would select it here, okay, so this is my quick preview of the level.gltf in Castle Game Engine editor, okay? And now what I actually want to do, of course, is just to place it. Okay, so I'm just going to drag it and place it like this on my screen. Now I'm going to actually, I mean, there are two ways now what I can do. I can take all my stuff that I have designed here and I can position it at a sensible place on my terrain, or I can do it the other way around. I can take this terrain and move it a bit lower, and now this way, like, make everything arranged in a sensible way. So let's delete this plane. Let's take this new scene from Blender that we have created. Let's press F like focus to make sure that we see everything. Okay, it's kind of black because the lighting is underneath it, okay? That's no problem. Let's just move this thing lower, and like this. And let's also make this terrain have precise collisions. This way it will react nicely with the walk navigation that I'm going to add here in a second. And that's going to be, I think, a good starting point for more fun that I want to show here. Let's move it here. So that's our, I guess, simple level designed in Blender from a terrain in some boxes, okay? And now I'm sure you can imagine how to do it 100 times better. So let's make sure that it works. So I want to add here a user interface navigation that will allow the user to automatically navigate in your world. Because by default, well, the camera just stands still and there is no default reaction to what user is pressing. You have to implement it, or, as I say, use our ready component that implements those reactions for you. So we have a walk component, the walk navigation component, that will kind of perform what you would expect in a typical first-person shooter games. So I'm just adding a walk navigation component to the viewport, and that's it. It will just work. It will allow the user to navigate in our world. And let's test it. So let's run the game. Yeah, and as you can see, I'm often like clicking at the camera preview before running the game, because this of course shows what the user will see once we will run the game. Okay, and that's it. So user has stayed on the ground correctly because the ground has precise collisions. Yeah, but we have again made the same mistake that I guess 5 minutes ago, because the physical objects, they fall through because the terrain, it doesn't have any collider. And that's of course very easy to fix. So we can add a behavior called mesh collider. And this way those objects will stay on our terrain. Let's first test running the physical simulation. Okay, it's better now. And now let's do another test by running the actual game. Okay, and everything falls down and everything behaves, well, in a way it should. Okay, let's do, and those balls, they will fall down into infinity soon. Let them go. Okay. So what more can we do here? Well, first of all, let's make our navigation a bit better. For the debug purposes, I have usually found that it's actually better to have some larger move speed, and also it's very useful in games to have something called mouse look. Mouse look means that when I will move my mouse around the screen, then it will translate to the rotations of my camera. So that's an easy way to rotate your camera, by activating the mouse look. Now let's do something more with physics, because okay, now we can drop those things, but that's not very interesting. Let's say I want to shoot something and I want this thing that I'm going to shoot to actually collide with other things using physics. Okay, how to go about it? Well, let's start with Blender. Okay, so let's start by designing some simple model that will act as a missile that I'm going to shoot. Okay, so let's go like this. Let's switch to the Blender front view and let's use cylinder, and I'm going to align the cylinder in this way. Okay, and now let's scale it because I want to create something like an arrow out of it. Okay, so this scale will work, I think. Yes. Now let's select this thing and extrude it. Okay, now I'm going to scale it and I'm going to extrude it again, and now I'm going to press M like merge. Okay, and amazing, this is my missile, this is what I want to shoot in my game. Okay, let's make it also shaded perfectly, and that's cool. That's the missile that I will want to use in my game to shoot stuff. Okay, so let's save it just like with the level. Let me save it as a Blender file. And then let me export it to the GLTF file, so the Castle Game Engine can actually use it. Okay, so let's switch those things. Again, actually the default ones, the default settings have been good. I guess now a habit to switch them. Okay, so now we have something called missile. Okay, so let me just do it like this. Okay, so the missile is visible here. However, well, okay, now how do I place this missile on my level? Sure, I can just load this GLTF file at runtime, but this would also not do what I want, because this way I won't have the physics components available on this missile. And I don't want to just add this missile to the level because, well, it's not initially present on the level. I want to shoot this missile, for example, when I press enter on my keyboard, okay? So the way to do it in Castle Game Engine is to create something called the design that will compose the scene with the missile with the components that determine how does this missile move from the point of view of the physics engine. If you come from the background of, for example, Unity, then you may recognize this pattern. In Unity, this is called Prefab, which stands for prefabricated object in Unity. So in Castle Game Engine, we have something similar. It's called the design, and it's basically a way to like compose visually a few components into something, well, into something bigger that you can then later easily instantiate from your code. Okay, so let's go ahead and let's create it. Let's create a new transform and the transform as root. And it looks like this, okay, so nothing fancy. Yeah, but now, okay, we're adding here a missile. And actually I don't want any transformation additional to be applied on this missile. And now, okay, so we have a scene with missile, and additionally now I want to apply here physics behaviors. So let's create a collider. Box is kind of okayish for this collider, okay? Let's make sure that the size of this box is sensible. Yes, it is. It matches the missile. And let's save it. And I'm going to call it just missile. So now I have the field called, the file called missile.castle. castle-transform in my data. And cool, this is what I will want to now load and like spawn when the user is pressing some keys, for example enter, something like this. And let's go ahead and let's actually do it, okay? So let's open our project in Delphi. Okay, let's go to the view main. And okay, now when the user is pressing some key, so when the user is pressing the enter key, okay, so that's my start. I want to spawn a copy of this missile, okay? How do I do this? Well, I want to declare the missile. It's going to descend from the castle transform class. This corresponds to this castle transform class at the root of this design. So that's why I'm declaring it here as descending from the castle transform class. Of course, I have to remember to use the unit when I should. Now, okay, so I have declared the missile. Now I want to load the missile, but I don't want to just create a new instance of this class. I want to load the instance of this class from file. And to do this, I'm going to use the transform load method, actually routine. It's a global one. And I'm going to here specify the field name missile.castle-transform, and it lies in the castle data, special magical data subdirectory, okay? So this file name corresponds to what I have set here. Okay, now this is a component, so it actually has to be owned by something. I'm going to assign an owner called freeStop, which means that if the view will switch to something else, which it will not in case of this game, but if this view would switch to something else, then the missile would get automatically destroyed. Okay, so now I have this missile in my hand. Well, by default it's not visible anywhere. I want to actually add it to the viewport, okay? So let's go ahead, let's switch to our view, and let's rename this viewport to something, well, let's call it meaningful, okay? So I'm going to call it main viewport. I'm going to declare it. Okay. And now here I can say, okay, main viewport, well, the main viewport has items. Oops. Of course, I have to add it to the users class, okay? So the main viewport has items, and this items is, well, it's what you see here in the custom game engine editor. The items is what is visible in the viewport. Okay, cool. So to the items, let's add our missile. Okay. Oops. Okay. However, now this is still too simple to actually make any sense, because now I have added a missile to the viewport, but at what point, at what translation is it added? What? At the default one. And with what direction? Well, with the default one. So it's just going to stand at the 0, 0, 0 position in my level, not even visible, and it's going to be pointing toward, I guess, the negative z-axis. So that's not very useful. So I want the initial position of my missile. It's called translation in custom game engine. I want it to correspond to the position of the camera. So, you know, I'm shooting like the missile from where I'm standing at. Okay, so let's use the viewport camera translation as a good initial position of this missile. I can also actually make it even like further, so like shoot it not exactly from my camera, but shoot it from some point in front of my camera, okay? So I could do it, I could do it like this, for example, okay? So okay, now the missile have a sensible translation. Let's also orient the missile so that it's directed correctly at the beginning, and to do this I'm of course adjusting the missile direction in the same way. So the missile direction, by default, it matches my camera direction. Okay, cool, and this way the missile will actually be oriented just like my line of sight. Okay, cool, let's see how it works. Okay, so I'm walking around and let me press enter. And that's what happens when I press enter, okay? I can press enter many times, and as you can see, yeah, the missile is now a physical object, and I'm just, you know, dropping it on the ground where I stand. So okay, that's, I guess, what was supposed to happen. So the position and the direction of the missile matches my camera, and it's a physical object, and I just drop it on the level where I stand. Okay, I guess the one more thing that I want to do is when I shoot the missile, I want to actually apply some initial speed to it, so it goes, well, forward instead of just falling down along with gravity. Now, the way to apply some initial speed, well, you can use Forces API to do it. You can apply some impulse or force at the beginning, but there's actually a simpler way in this case, which is to access the rigid body component of this missile and just apply some initial linear velocity, so that the missile will fly with some velocity, yeah, just as it should. Okay, so how to go about it? So I want to access the rigid body component of this missile. I have already designed this component. As you recall here, this transformation has a component rigid body of the class T castle rigid body. And okay, this is actually, well, there are multiple ways to access it, but this way is actually the easiest in this case. So I can go ahead and on the instantiated missile, I want to find behavior with a class T castle rigid body. And I know it's going to be there because I just did it, so I just added it there. So I can actually, in case of this demo, I can just assume that it is there, okay? So this is this definition and a way to operate this physical body. And what can I do with it? Well, it has the property called linear velocity that I'm now going to adjust. So I want the velocity of this missile to be just like direction that I'm looking at, but I want it to be larger. Yeah, the length of this vector is meaningful, so I want to do it like this, and this way the missile will actually fly forward. Okay, and now, as you can see, I can shoot with this missile, and it bounces correctly off the terrain. It bounces correctly off everything else. In particular, I can shoot this sphere. Yeah, go. Yeah, so I can now play around like this. I can do some really crazy thing, as you can see, terribly fast. Amazing game. Yeah, so I can do some crazy thing with physics, and this way incredibly fast. The thing flies with physics, the thing collides with everything else that is affected by physics, including other missiles, terrain, those spheres and boxes that have, I guess, long gone now into oblivion. No, there's this. Okay, I will leave. So yes, I can do everything I want to with physics, and it's a lot of fun, I guess. Okay, so what more could we do here with this? So we can now shoot things, and they collide with other things. I guess the last thing that I want to show in this physics demo is how to make an explosion. So imagine that you want to have like a center of explosion, and when something happens, for example, when I press some button, I want this thing to like explode, which means that every other physical object should like bounce off it, okay? So it like go around a bit, okay? So how would we go around making it? Okay, so let's start by going to our level, and let's actually put something that will represent our explosion center at our level, okay? So I'm going to just use a simple sphere for it. Let's assign the color to it. Just like this. Okay, so this is going to be our center of explosion. I'll let it lie here, like on the terrain, okay? So this is our center of explosion. Let me rename it actually explosion center. Yes, okay. Now I want to access this explosion center from the code, of course. Okay, and I guess one additional thing that I want to do is I want to have a button to actually activate this thing. Okay, so I want the button to make it explode, and just like last time, let's make it a big button. Alright, so this is the button that will, I guess, make everything go boom. And now I want to handle user clicking on the button by causing the actual explosion. There's one detail here actually. In order to click on this button, I will have to deactivate the mouse look. So let me just do it by the way. Okay, so I have the button explode. I also have the main walk navigation. I want to declare it. Okay, now two things. When user presses escape, I want to toggle the mouse look on and off so that you can actually click on the button, okay? Because otherwise the mouse look will kind of hold your mouse glued to the window and you will not be able to actually click on the button. Okay, so toggling the mouse look is, I guess, simple enough. If event is key, escape, then toggle the mouse look. Okay, and the next thing is handling this button explode. As you can guess, I will want to have a method called explode that actually reacts to it. Okay, so I have a button explode. Let me assign an event to it. On click, explode, cool. Okay, and now let's actually define. So I guess let's do the main thing that we have came here to do, which is to define what happens when you press on this button to explode. So what I want to do is I want to enumerate all the physical objects that are in my world. In order to do this, one way is to use something called find all behaviors, and if I run it on the main viewport items, it can find all the behaviors present in my viewport. So everything that I spawned, everything that was already there, all those things will be found by find all behaviors. And I go and I want to find everything that has a physical body. So I want to find T custom rigid body, all the T custom rigid body instances. Okay. And what we are going to get from this is a tcastle behavior list, and we're going to iterate over it, right? Let's make sure to also free it. Oops. Okay. Now for behavior, in behavior list, okay. Now each of those behaviors, I know that this is a rigid body behavior. Okay, cool. So I have a behavior and I have a rigid body. Okay, so this is, I guess, a bit of boring piece of code that says, okay, take all the tcastle rigid body instances present in the viewport. Now iterate over them, access all of them as a rigid body, and now to the good stuff, okay? So what can I do with this rigid body? Well, I want to, the easiest way, I guess, to make an explosion is to apply an impulse on every physics body around me. And the impulse has two things. The first parameter, the impulse, it's actually a direction. So it's a direction along which the force will act on this object. And the second parameter is a point position from which this force will act. And I know both of those things because now I have this explosion center, right? I have defined this object called explosion center. So this is great. This is my position from which the explosion occurs, okay? So let's define a vector, center. Is defined like this. So this vector, I know the center because the center corresponds to the translation of my explosion center object in world coordinates. Cool. What more can I do? Well, I want this. So I want that the direction that is affecting the force that is affecting this given object, well, it's kind of directed from the explosion center toward the object that it is affecting. So in mathematical terms, this is a subtraction. So I'm taking the middle of the object that I want to affect. Okay, again using the word translation, and I'm subtracting it from the center. Okay, and this is the direction that I want to use. And the position from which it acts, well, it's the center of my explosion, right? If I could also adjust actually the strength of this explosion, because, well, the length of this vector, well, it depends on the distance from my object to the explosion center. Maybe it actually makes sense, but let's say that for this case I don't want to actually make it matter. So instead I want the strength of this explosion to always be, well, 10, because that's what I invented right now. Okay, cool. So let's see how it works. Okay, so now we have our project. We have our explosion center waiting for us nicely at this place on the terrain. And yeah, we have this big boom button waiting for us to be clicked. And the escape key allows me to go in and out of the mouse look so that I will be able to actually press on this escape key. So let's press it, okay? So boom. And now everything that I have defined is like goes away from this explosion center. But of course I actually want more things. So let's just shoot some rockets. I should have actually made those rockets slower so that they will be easier to control this way. Oh, and let's go like this, okay? So now I do want to have actually this slower rocket, something that I didn't want to do earlier. And let's try this one, okay? Boom! And that's what I wanted to do. Okay, so that's, I guess, the simplest, maybe not the simplest, but this was one of the simpler demos of how we can use the physics engine in Castle Game Engine, Editor, and from code. What more? Well, I want to mention that, well, we have a number of demos of this physics engine in our Castle Game Engine examples. And in particular, well, I want to emphasize that it all works not just for the 3-dimensional objects, but also for 2-dimensional objects. So let's open a demo called 2D game Sopwith, and it's designed like this. Okay, so there is some 2-dimensional object with a rigid body and a collider. And let's see that it works nicely at runtime. So I can move this plane, and it's shooting some spheres. They are actually spheres in 3D, and those spheres hit some boxes. Finally, we have also joints. Joints allow you to connect a number of rigid body components into something, well, that like stays together, following some rules. So let's actually run the demo, and then you can. It's definitely easiest to explain how it works. So, for example, this is the joint of a hinge. So what happens if I shoot this is that one rigid body is connected using a hinge joint to another rigid body. And when there is a rigid body that actually causes this thing to rotate, well, it doesn't just fly off. Instead, it stays connected to the wall. I mean, this pretends to be a door that is connected to a wall, and it just rotates around the hinge like a door would. Okay? And there are a number of other joints like following, I would say, this pattern. So let's run this demo and see. Okay, so this is the hinge joint. This is, I guess, a prettier version of it designed using Blender, and in particular you can see here that some joints can be made like breakable. Like, for example, this door, it has been actually made, it's a breakable joint, which means that if you apply force to it with enough strength, then actually the joint will break. So it kind of translates to exactly the same thing in reality. Like if you bash on something hard enough, then yeah, the constraint will eventually break. And there are more joints, like this is the ball joint that allows one thing to rotate around another with well, a complete freedom how it rotates. Another thing is the grab joint, and this means that when I click somewhere, the objects, the physical objects goes to where I clicked, but it's still following like the rules and the collisions of physics. So it's not going instantly, and it's also not going through if something is preventing it, it like has to push those other things through. Yeah. So this thing like is a magnet essentially in reality. Okay, we have a rope which allows one thing to dangle from another while keeping some sensible distance. And finally we have a distance joint, which is kind of like a rope too, except it's flexible, so it can behave like a spring. One thing keeps to another thing, like tied with an elastic spring, and yeah, it can like bounce, it can be more or less rigid essentially. Okay, and that's everything I wanted to talk about during this talk. So, as I mentioned, the engine is like, as I kind of emphasized at the beginning, the engine is open source game engine. Go ahead, download it. It's for free. And also, if you like what I see, if you like what you see, if you like what I talked about, go ahead and sponsor us, support us on Patreon. We very much count on your support. We right now hire one developer, Andrzej Kliański, who is working on the engine. We basically want to be able to hire more people and have more time to work on the engine and yeah, do more amazing features. So thank you very much for your attention, and yeah, I'm open to questions. Thank you. Bye bye.
Awesome, fantastic, thank you. You want to? It's Michalis. I'm not sure. Actually, go ahead and come on. Let's do some Q&A here.
My name is Michael. That's actually
Michael. Okay.
It's just Michael. It's a weird name.
All right. I tend to make names too complicated. I'm not very good at it. And so I was saying, Ian and I were talking in another chat about Castle Game Engine is so cool. Laura says as well, impressive demos. I agree. I've tried to do some stuff with. Oops, that was the wrong one. I've tried to do some stuff with Blender before, and I'm just not any good at it. And watching you do is, I'm like, oh, wow, that's amazing. But so the question is, what formats can you support besides Blender for 3D models?
Well, actually, we don't support Blender like natively. We don't load Blender models directly. We support a few. We have, I think, 12 of them by now. So I guess the main one is the GLTF. GLTF is kind of a standard format developed by Kronos. It's supported by, you can do it from Blender, from 3ds Max, from Maya, and so on and so on. So I would say GLTF, X3D, Collada, Wavefront OBJ, STL, and something else, I don't remember. We have like 12 formats basically that we support. Our goal is not just support Blender. Our goal is to kind of support every authoring software that you can possibly use. And for every authoring software, I'm guessing that we will find some format where we can read something that comes out of it. So we don't really need Blender. But in short, GLTF is what we recommend because it has an extremely good feature set, and it just works with a lot of software. Like I said, Blender, 3ds Max, Maya, those are covered. Use GLTF.
Now, as far as like animating parts of a model, right? So you had just the models moving it as a whole. Is there a way to like move the arms or stuff like that within Castle as well?
Yeah, exactly. I mean, we support skinned animation. So you design it in Blender, and then you export it to GLTF, and then yeah, we render it in Castle Game Engine. So this is absolutely supported. I mean, the one thing that we're actually missing is that what you can do right now is that, for example, you can make a character that has the name has a hand animated, for example, something like this. What is still to do is actually to give you something called inverse kinematics, which means that you would also be able to, for example, from code, say where does this hand go and control it. So this bit is still to do, but it will also come. Yeah.
Mm-hmm. Okay, very cool.
Thank you for the good comments.
Exciting comment. Yeah.
Thank you for the good comments.
Honestly, I'm watching this and I'm like, I've seen you do this before, but every time it's so impressive and it's so cool. And you're doing like all this in real time too. And I'm just like, this is amazing.
Thank you, everybody. I see just some positive feedback. Thank you, everyone.
Yeah, so everybody go out to Patreon and sign up to support Castle Game Engine. That's a great way to show your support and show your appreciation. And I will be back out there again too, I think, as well. Let's see. What about like particle animation, right? So like in your explosion, is there a way to add particles or stuff like that, debris?
We don't have it as a core in the engine yet. So like the particle engine is a well, I kind of didn't have basically resources to kind of attack this feature, but we actually have a dedicated person, Kagama, on our Discord and GitHub, who has made actually two implementation of physics, or not physics, particle effects for Castle Game Engine. One of them is using something called FXeer. It's kind of an external library to define effects, like particle effects, and you can define them so like in an external editor and then load them in Castle Game Engine. And another approach that he did, and he's still doing it, I mean, he's still maintaining it, is that actually a way in our Castle Game Engine editor to design particle effects. So basically, it's not part of the Castle Game Engine core, but there are at least two like powerful, very much practical and powerful approaches to do this in external open source components developed by Kagama, Nikon Discord on GitHub. He's doing a lot of great things around Castle Game Engine. At some point, I suppose one of those two methods will win, and we will, integrate them actually in Castle Game Engine core, of course. But for now, you can use it already.
Okay. Here's a question: can Castle Game Engine render spline curves for creating things like roads?
Yeah, I did answer that one already because I was answering in parallel. We can render spline curves, we can NURBS, spline, we can render them all. You can also load them in the engine and basically from code do what you want with them. For example, build something along the spine or animate something along the spine and so on. So yeah.
Okay. Hey, Patrick, apparently I'm fighting here. Patrick put the link in for your Patreon, Castle Game Engine on Patreon.
Very much. Yeah, I would add to the Patreon that, the goal here is to just hire people. To have more time and to hire people. We already have Andrzej Kiliański. What you see in this demo has been developed, not by me, I couldn't do it, by Andrzej Kiliański, who did it, and then using Craft Engine from Benjamin Rousseau. And then maybe, I guess I just helped a bit. But it is not a work of myself. It's a work of a few people. And the idea of Patreon is to support them basically so that we have more time to do more of this. Yeah, thank you.
All right, fantastic. We need to wrap up here. Sandra says you code too fast, hard to read everything. Which you're still at the end that you have demos that we can check out. So yeah.
Yeah, indeed. I answered Sandra already in the chat. Basically, what I show in this presentation is kind of a combination of two demos that you can find source code for them in the engine sources, and look at them for yourself.
What it's probably on the website, but what platforms can you target from Castle Game Engine? It's quite a few, I believe, isn't it?
Yeah, in general, quite a few. So Linux, FreeBSD, macOS, Windows, of course, on mobile, Android, iOS, and finally Nintendo Switch. Oh, and Raspberry Pi also. That's a Linux too. However, there's a disclaimer here, but one that will rectify it. But with Delphi, so far we just support Windows. Which simply didn't have resources like to port our other platform support to Delphi. But this is going to be rectified. We want to support other platforms. The ones coming sooner with Delphi are going to be Linux and Android. In fact, there has been kind of a successful, like a fundraiser for one person who's developing actually a game for Android using Delphi, and they wanted this support and they made funds basically to support exactly this particular development. Android with Castle Game Engine on Delphi, and they succeeded. So it's going to happen. So with Delphi, just Windows, but this is going to get better.
Fantastic. So I like the fact that you can compile, and you showed both compiling it from Castle Game Engine versus from Delphi IDE, and you can use the compiler or the debugger and stuff. And so I'm assuming that if you are targeting if you want to target like Switch, right, then your loop would probably be similar to what you're showing today, and you'd be developing and testing on Windows, and then test to Switch occasionally. Would that be probably your would look like.
Exactly. I mean, when you're doing basically anything that doesn't work on desktop, even Android or iOS, it's kind of easiest to just keep testing it on whatever Windows, Linux, whatever you're working on, and then just I guess, from time to time, recompile it for the platform. I mean, you can do it as often as you like, but of course, it's 2 seconds to just see it on your Windows, and it's, at least 15 seconds to see it on your Android. So it's always going to be faster to just keep testing on your desktop. Yeah. And do you support Animation Blender? I see the question already. Yes, we do support Animation Blender. When you play an animation, you can tell what is like the crossfading time. So you can crossfade to animations with any time that you want to, and you can also customize this time per animation. So yes.
So there's a question here about Adobe, but I'm assuming this goes back to the other thing of just exporting to one of the 12 formats that you support.
Okay. Yes, here I guess an important mention about Adobe is that Adobe is kind of, I want to say pushing, but let's say promoting their proprietary 3D format that's called FBX, and we don't support it. We do support, however, GLTF, and you can export to GLTF from 3ds Max, Maya, so Adobe products. So we do support Adobe products like 3ds Max, Maya through open formats like GLTF. There may be at some point a support for something like FBX. If I'm guessing right, then maybe you're asking about FBX, but not right now. Right now, our recommendation, even if you're coming from Adobe products, is to use GLTF as kind of an intermediate format. Because it works good, and we have documentation on our website also, particular for 3ds Max and Maya, how to use them properly. I hope I did remember, because they are from Adobe, right? No, Autodesk. I mixed it up. Okay, so I guess my answer for the Adobe question may have been completely idiotic. So sorry about that. And if you want to make it better, go ahead and I guess ask me later, because we may support something that is connected to Adobe, and I will be able to answer you better. Yeah. Okay.
One more question, and then we're going to the next section. Is there one of the things about game development is a lot of times I'm not very artistic, so I'm not going to be able to develop the models myself. Are there any good places you found, like third-party marketplaces, to pick up models and assets and stuff like that you can use in Castle Game Engine?
Actually, quite a lot, and it depends on whether you want to pay for them or download for free. But actually, we do have a lot of sites that allow open source, like on the open source licenses and for free formats, yes. And actually, there is a collection of links that you can use. If you go to the Castle Game Engine website, you can click on Gallery. You can click on the Gallery and then go to the Assets. And so we have a dedicated link from 2 websites from which we recommend you to download assets, because they have 1, good quality, and 2, they are on clear open source licenses. So public domain, Creative Commons, and so on. So actually, there's a few of them. There's not a few, a lot actually, enthusiastic people doing really high quality and also free assets on the internet. And you can basically use them. Thank you. Exactly, Patrick. Right. That's the link. Thank you.
And there's the direct link to the assets. Fantastic. All right, great. Very exciting. Very excited. Thank you so much for all your work in promoting this. And what is your role? Are you managing it, since you said you're not the developer for this, or what is your role in Castle Game Engine?
I'm still a developer. Okay. Yeah, I'm the original author and I'm still the developer. I guess I'm holding all the keys and I'm still developing a lot of this stuff. But I am also overseeing, I guess, some work that happens. But I still code.
Yep. All right, cool. Thank you so much for your work, and thanks for all your team. Let your team know we appreciate it, and we're very excited about all the stuff you have going on here. So,
thank you very much.
All right, and we'll see you later. Thanks.
Yeah. Thank you. Bye-bye.